one, what we have to do is we have to find polar coordinates that represent the same point. Well, if I have 3 pi over 6 and we graph this, it's going to look like I have my pi over 6 here, and I have 1, 2, 3, right? So that is this in polar form. Now, if I have to find for letter A, r has to be greater than 0, and my angle has to be between negative 2 pi and 0. Well, since it's positive, what I could do is I could just subtract 2 pi from this, and I will get A. So for A, my answer is just really 3. Then I'm really going to take pi over 6, and I'm going to subtract 2 pi, which is 12 pi over 6. So my answer for A will just be 3, negative 11 pi over 6, which is the same point that I have here. Okay? For B, I want my r to be negative, and then I want my angle to be between 0 and 2 pi. Well, remember that if the r is negative, it really represents the ray that's opposite. So the ray that's opposite, to find the ray that's opposite, I just add half a revolution. So for B, I am going to add negative 3. Negative 3 is my r, I mean. And what I'm going to do is I am going to add half a revolution. So I'm going to add pi, which is 6 pi over 6. So my answer here will just be negative 3, 7 pi over 6. Okay. And then for letter C is I want r to be positive, but I want the angle to be between 2 pi and 4 pi. Well, since it's already between 0 and 2 pi, to get it between 2 pi and 4 pi, I'm just going to add another revolution. So for part C, it is just going to be 3 pi over 6 plus 12 pi over 6. And so my answer is 13 pi over 6. So that's number 1 on the study guide. Let's go ahead and work number 2. Now, number 2 is the same thing. If I have negative 3, negative pi over 4, okay? If I graph this, here is negative pi over 4. And since it's negative, I'm not going to go here. I am going to go the opposite ray. And I'm going to go 1, 2, 3, and that is my point. Okay? Now, for letter A, I want r to be positive. So I know for letter A, r is going to be positive, which is 3. And I want to be between negative 2 pi and 0. Well, if I look here, I need my angle to be negative. So the best way to do it is just to look at my picture, and what is this angle this way going in the negative direction? Well, the angle going this way is negative 5 pi over 4. So for here, I'm really just looking at the picture and determining the angles from the picture. For letter B, I want my r to be negative, so it has to be negative 3, and I want to be between 0 and 2 pi. So if B is negative, negative 3, that means I could go to this ray here, right, which is 7 pi over 4. Okay? See, if I'm at 7 pi over 4, and I go negative 3, then I get on this ray, and I'm going to go 3 this way, so I end up at the same point. And letter C, I want my r to be positive, so it's 3. And I want to end up with an angle between 2 pi and 4 pi. So this is 5 pi over 4. I mean, sorry, This is 3 pi over 4, so I'm just going to add another revolution to it. So this is going to be 3 pi over 4 plus 8 pi over 4, since that's 2 pi. So my final answer for C is 3, 11 pi over 4. Okay. Number 3 and number 4 are pretty straightforward. Number 3, if I want to change 6 and 150 degrees into polar coordinates, x is equal to r cosine theta, and y is equal to r sine theta. So x will just be 6 cosine 150, and y will be 6 sine 150. If I take the cosine of 150, cosine of 150 is my 30-degree angle in quadrant 2. So I just use my fingers to find 30 degrees. The cosine is root 3 over 2. But since I'm in quadrant 2, my value here is negative root 3 over 2. So x is equal to negative 3 root 3. And y is equal to 6. The sine of 150 is 1/2. So y is equal to 3. So 6 150 degrees in rectangular coordinates is negative 3 root 3, 3. Number 4 is exactly the same way. I'm not going to do number 4 on the board because I want to move on. But for number 4, check your answer. Your answer should be x is equal to negative 1/2 and y is equal to root 3 over 2. That's the answer for number 4. Try it on your own. If you have any questions, you can email me. Okay. Now, let's go to number 5. Number 5, I'm changing rectangular coordinates into polar coordinates. So for number 5, I have the point 0, negative 5. 0, negative 5, I'm on an axis. So all I really need to do is just draw it. 1, 2, 3, 4, 5. And in the drawing, I know what is the polar coordinate, the point in the polar coordinate that represents that. Well, since I'm here, I could just count. It goes 1, 2, 3, 4, 5. So my r is 5. And my angle here is 3 pi over 2. So in polar coordinates, it's 3 pi over 2. I don't care if you use degrees. This could be 5, 270 degrees. You could even do 5 negative pi over 2. That also works. Negative 5 pi over 2 also works. Any of these answers will work. I'm only looking for one, so I'm sure most of you will give me either the basic one that's like this. Okay? Number 6. Number 6 is 3, 0. So I am 1, 2, 3 here. So my point in the polar coordinate system has an r of 3 and an angle of 0. So it's 3, 0 degrees. Or you could even do 3, 360 degrees. It could be even negative 3, 180. Okay. You could use radians or you could use degrees. It doesn't matter. So this could be 3, 2 pi. Okay. Now number 7 is where the point is not on the it's not on the axes. So we have to do something a little bit different for number 7. Number 7, my point is root 3, 1. So to find my r, I take the square root of root 3 squared plus 1 squared. So my r is the square root of 4, which is 2. Now, to find my theta, I take the tangent. Tangent theta is equal to y over x, so it's 1 over root 3. If I rationalize that, I get tangent theta is equal to root 3 over 3. And then you could use your tangent table to find that theta is equal to pi over 6. So I have my r, I have my theta, so in polar coordinates, this is 2 pi over 6. Okay. Number 8. Number 8 is exactly the same as number 7. So number 8, I have negative 0.8. It just gets funky with the decimals. So you would just use your calculator for this one. R is equal to the square root of negative 0.8 squared plus the square plus negative 2.1 squared. When you work it out, you should get that R is equal to the square root of 5.05. Sorry. So I do tangent theta is equal to negative 2.1 over negative 0.8. If you do the inverse tan on the calculator, you'll see that theta is equal to 69.1 degrees. So my point is 5.05, 69.1 degrees. Okay. Okay. Now, number 9, I'm going to transform each of these into rectangular coordinates. And then I'm just going to describe the graph. I'm not going to go ahead and graph the graph. But if you have any questions, please let me know. Or maybe I'll try to quickly sketch it. So for number 9, I have r is equal to 7. Well, what I'm going to do is I'm going to square both sides. So r squared is equal to 49. R squared is really x squared plus y squared. So that is my answer. It's a circle with a radius of 7. So on your polar graph, if this is your center, and you should have a radius of 7. So just count on your graph the lines, the circular lines 1, 2, 3, 4, 5, 6, 7, and you should have a circle at the r equals 7. Now for number 10, when you have an angle, what you want to do is you just want to take the tangent of both sides. So I'll have tangent theta is equal to tangent pi over 6. So this becomes tangent theta is really equal to y over x. And if I use my tangent table, tangent of pi over 6 is root 3 over 2. I solve for y, so y is equal to root 3 over 2x. And when you graph it, basically if you have your circles going around this way, pi over 6 is 30 degrees, so on your 30-degree line, you should have a line going this way if this is pi over 6. Okay? Now for number 11, is r sine theta is equal to 5. Well, this one's a really simple question. R sine theta is really just y. Y is equal to 5, so this is a horizontal line. Through y is equal to 5. Okay? So on your graph, it should just be a horizontal line through 5. Number 12, it's r cosine theta is equal to negative 1. So this is x is equal to negative 1. So this is a vertical line through x is equal to negative 1. Number 13. Number 13 is going to be r is equal to negative 3 sine theta. I'm going to multiply both sides by r, and I get r squared is equal to negative 3r sine theta. I replace r squared with x squared plus y squared, and I replace r sine theta with y. I'm going to move the negative 3y to this side, so I have x squared plus y squared plus 3y is equal to 0. And then now I'm going to complete the square. So this is x squared plus y squared plus 3y. If I have 3, it's 3 halves, and if I square 3 halves, I get 9/4. Okay, so I have to add 9/4 to this side. So when I complete the square, this is going to be y plus 3 halves squared is equal to 9/4. When you graph this, your center, I'm going to put it here, your center should be at 0, negative 1.5, and you have a radius of the square root of 9/4, which is 3 halves. So you have a radius of 1.5. Okay. Okay, number 14. Number 14, you have r secant theta is equal to 2. Remember, secant theta is really the reciprocal of cosine. So now I'm going to get the r by itself. So r is equal to 2 cosine theta. I multiplied both sides by cosine theta if you were wondering what happened here. And then so I'm going to multiply r on both sides. I get r squared is equal to 2r cosine theta. R squared is x squared plus y squared, and r cosine theta is x. I complete the square here. I'm going to get x squared minus 2x plus y squared is equal to 0. This becomes x squared minus 2x. Half of negative 2 is negative 1. I square that, I get plus 1. So I have to make sure I add 1 over here. So this is x minus 1 squared plus y squared is equal to 1. So your center should be at 1, 0 with a radius of 1. Okay. For now, I'm going to skip the graphs of the polar equations. I'll get to that a little later, but I'm just on a time crunch now. Because I'm actually going to go watch the musical later, so it's almost time for that. So I want to go to number 18. Now, number 18, there's a mistake here. There shouldn't be a square root going across the entire thing. So number 18, fix that it should be z is equal to 9 root 3 plus 9i. Okay, so r is equal to the square. So to find this complex number in polar form, I have to find my r and my theta. So r is really just 9 root 3 squared plus 9 squared, because remember, r is equal to x squared, the square root of x squared plus y squared. So r is equal to, remember, 9 root 3 is really 9 root 3 times 9 root 3. So 9 times 9 is 81. And root 3 times root 3 is 3. So 81 times 3 is 243 plus 81. So this becomes r is equal to the square root of 324. So r is equal to 18. Okay? Now, I need to find my angle. So I know cosine theta is equal to x over r. So it's 9 root 3 over 18, which reduces to root 3 over 2. And sine of theta is equal to 9 over 18, which reduces to 1/2. I use my fingers and I find where is the cosine root 3 over 2 and where is the sine 1/2. That's at 30 degrees. So I know theta is equal to 30 degrees. So if I write this out in polar form, z is equal to 18 cosine 30 plus I sine 30. Okay, so that's number 18. Number 19 is actually one of the most easiest questions here. 19, if I want to do this in rectangular form, if I have 0.4, oh, there's a mistake here. Make this cosine of 210. Because the cosine of 200, we had to use a calculator, and I want you to practice with the unit circle. Okay, so 210 is really the 30-degree angle in quadrant 3. So quadrant 3, so 30 degrees your cosine is root 3 over 2, and your sine is 1/2. But since you're in quadrant 3, your cosine should be negative root 3 over 2. And then this is going to be negative because minus 1/2 I. Because the sine is 1/2, but since you're in quadrant 3, sine's negative. So this simply becomes, if I distribute, this becomes 0.2 root 3 minus 0.2 I. Okay? Okay, number 20. Number 20, you just have to follow the convention of multiplying and dividing complex numbers in polar form. What you do is you multiply the r's. When you find the product, you multiply the r's and then add the angles. When you find the quotient, you divide the r's and then you subtract the quotients. Just look in the other video for a more detailed explanation. But for 20, your answers for z times w should be 8 cosine 60 plus I sine 60. And then z over w is really 2 over 4, which reduces to 1/2. And then I have cosine 20 plus I sine 20. For 21, I'm using de Moivre's theorem. So 21, if I have 2 cosine pi over 10 plus I sine pi over 10 to the 5th power, okay? This simply becomes 2 to the 5th times cosine of 5 times pi over 10 plus I sine 5 times pi over 10. And so 2 to the 5th is 32. And this becomes the cosine of pi over 2 plus I sine of pi over 2. If we were told to leave it in polar form, this would be the answer. But it says to find it in standard form, so we have to evaluate this. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So that just becomes I. So my answer here is just 32I. Okay. Last one that I'm going to do is 22. 22, I am going to use de Moivre's theorem to express root 3 minus I to the 6th in standard form. So I'm going to find my r first. R is equal to root 3 squared plus negative 1 squared. That equals the square root of 4, which is 2. Now I'm going to find my theta. So cosine theta is equal to root 3 over 2. And sine of theta is equal to negative 1/2. The angle that has a cosine of root 3 over 2 and a sine of negative 1/2, the angle is going to be 330 degrees. Okay? But I'm actually going to make this, let's just do that now. So if I write this using de Moivre's theorem, it's going to become 2 to the 6th cosine of 1980, because 330 times 6 is this, plus I sine 1980. Now, 1980 is a big number, but what we could do is we could keep subtracting 360 to figure out what this is between 0 and 2 pi. So this is 2 to the 6th, and it's actually cosine of 180. See, it becomes really nice. Okay, 2 to the 6th is 64. Cosine of 180 is negative 1, and the sine of 180 is 0. So my answer here is just negative 64. Okay, and that's all I have for now. If you weren't here for the complex roots, I might put a video on that a little later, but for now, we're going to keep it here.